All right, we are in Chapter 14, Systems of Equations. Let's take a look. Okay, so on this first problem, they are asking us to solve the following system by graphing. Now realize if we were wanting to graph this properly, we'd generate some graph paper and we'd get ourselves a little bit more precise. But we're going to use just x and y graph. We're going to rearrange these equations into slope-intercept form so that we get y equals negative x plus 9 for our first equation, and y equals positive 2x for our second equation. And for our first equation here, y equals negative x plus 9, we'll start up here at 9. That's our end point. And for each step, we'll go over one and down one, which means that over here on positive 9, that's where we're going to cross. And then for our other equation, up here we'll start at 0, 0. That's our y-intercept. And at 6, 12, that's where that will go roughly. And where it intersects, the intersection point is going to be 3, 6 for our graphing solution. Once again, doing that on graph paper, maybe using a software program like Desmos just to visually check with that if you had to graph several points or lots of details. Okay. Solve this system equation by substitution. So we've got our first equation, 2v minus 2i equals 16. We are going to plug in 2i in for 2i, this value. So we'll have 2v minus, and in place of 2i we'll do v plus 9 equals 16. I will distribute the negative sign so we get 2v minus 9 equals 16. We're going to add 9 to both sides. Combine the v's and we get 1v equals 25. Then we're going to plug this back into our other equation. So for our I, we can say 2i equals 25 plus 9. That gets us to 34 equals 2i divided by 2. We'll get I equals 17. Okay, for question number 3, we've got a couple of equations. They want us to determine the solution of the system. So we're going to use an elimination method here. We're going to write V1 minus V2 equals 23, and we're going to drop the volts unit here. And then we'll rearrange this equation so it's V1 plus V2 equals 57. We're going to add the two equations together, realizing that when we add these V2s will cancel out. So we get 2V1 equals 23 plus 57. So on our calculator, 23 plus 57, we get a grand total of 80. We can divide both sides by 2, and we get V1 equals 40. Then we'll plug V1 into this second equation, so that's 40 plus V2 equals 57. We'll subtract 40 from both sides. So if we do 57 minus 40, we get 17. So V2 equals 17. So this is the elimination method. We're going to solve number 4 similarly. So with this, if we just straight up added the equations, notice they wouldn't cancel out. But because we have a positive and a negative here, if we had 3 here, that would cancel out. So we'd have to multiply everything by 3. And so let's do that. 3x plus 3y equals 32 times 3. That gets us 96. And then we have 7x minus 3y equals 29. We can add both equations together and get 10x plus 0y, so our y's cancel out. And we have 96 plus 29, and we get 125. Okay, this gives us 10x equals 125. We can divide both sides by 10. We get x equals 12.5. All right, for our y value, we can plug in. So we'll go back to our original x plus y equals 32. And we'll plug in 12.5 for x plus y equals 32. We'll subtract 12.5 from both sides. So 32 minus 12.5 gets us, for y, equals 19.5. So that's the elimination method. Next page. Okay, solve the following systems of equations. So this one's a little bit more complicated because now we have 3 equations that we have to solve into. So I'm going to rearrange the first equation so that it is z equals 15 minus x minus y. And then I'm going to use the substitution method and plug it into our other 2 values. So we'll have 5x minus z, which is 15 minus x minus y, equals 18. From here, we'll distribute the negative sign, so 5x minus 15 plus x plus y equals 18. We'll add 15 to both sides. We'll combine the x's, and we'll get 6x plus y equals 18 plus 15, and get ourselves 33 here. So this is one of our new equations. Now we're going to use this value, so we'll start with our 4y plus z, and instead of z, we'll put this in, 15 minus x minus y equals 19. We'll combine our terms here, so we get 3y, and we'll subtract 15 from both sides. So we get negative x plus 3y, and then 19 minus 15 gets us our 4. And so now we have 2 new equations that we're working with. We have negative x plus 3y equals 4, and we have 6x plus y equals 33. So this is taking it down from 3 equations and 3 unknowns to 2 equations and 2 unknowns. Notice we have a negative here, so we're going to use these 2, and we're going to start up our next piece. So let's see if we can just, got some space, we're going to work with these 2 equations. So I've got negative, oops, I'll switch my color back to black, negative x plus 3y equals 4, and I've got 6x plus y equals 33. I want to cancel out the x's, so I'm going to multiply the top by 6. So we get negative 6x plus 18y equals 24. Notice we multiplied by 6 across the whole thing. Then we've got a positive 6x plus y equals 33. We're going to add them together and we'll get 0x. We'll get 19y equals 57. Divide by 19. We get y equals 57 divided by 19, which is a 3. And now we can plug this back into any of the equations and solve. So I'm going to use the 6x, which is unknown plus y equals 33. We'll plug in 3 there, so 6x plus 3 equals 33. Subtract 3. We get 6x equals 30. Divide by 6. And we get x equals 5. And that lastly for our z, we'll have x plus y plus z. So 5 plus 3 plus z equals 15. This is 8, so we can subtract 8 from both sides. And 15 minus 8 gets us 7. So we get z equals 7. So 5, 3, 7, or if we wanted to write this in the coordinate system, our x, our y, and our z. Okay. Okay, we've got an equation where Henry can buy 35 of the 20-watt spiral, so we're going to call this X, and the 25-watt spiral we're going to call Y. So he can get 35X plus 20Y, and he'll pay $352.15. For the other equation, he could buy 45 of the 20 watt, which is X, plus 10 of the Y, and he'll spend $344.65. So I notice here on the Y's, this is 2 times bigger. I'm going to multiply this bottom whole equation by a -2. So that will get we'll keep the 35x plus 20y equals 352.15. And then -2 times 45 is going to be -90x. -2 times 10 is going to be -20y. And 344.65 times a -2 gets us -689.30. We're going to add these two together. So 35 plus -90 gets us -55x. Our y's add to 0. We have 352.13 minus 689.30, and we get a -337.17. We'll divide both sides by -55. So divide by -55. We're going to round this to the nearest penny. So for our x value, we get $6.13. And then we can just plug this in for our y value. So if we have 45 times 6.13 plus 10y equals our 344.65. We can multiply these two numbers together. 45 times 6.13, and we get, that's 275.85. So we'll subtract that from both sides, 275.85, leaving us with 10y equals, subtract the 275.65, 69 divided by 10, so we get y equals $6.90. Okay. Our next equation. We can plug in this directly in for the x, so we get 2y minus 6 plus y equals 48. We can add 6 to both sides, and we have 3y equals 48 plus 6, which is our 54. And if we divide both sides by 3, we get y equals 18. So then we can say that x equals 2 times 18 minus 6. And so for x we get 30. Okay, for our next systems of equations, we're going to substitute for one of these. So we'll rearrange this first equation and say that x equals 6 minus y, and we'll plug it into the other two equations. So for this first one, we will have 6 minus y plus z equals 8. And we'll subtract 6 from both sides, so negative y plus z equals a positive 2. And then this other equation already has our y and a z, so we can write that. So we've got our y plus z equals 10, and we'll use this equation, negative y plus z equals 2. We'll combine them because automatically the y's cancel out. We get 2z equals 12. Divide both sides by 2, and so we get z equals 6. Then we can plug this back into this equation. Negative y plus 6 equals 2. We can subtract 6 from both sides. We get negative y equals negative 4. Divide both sides by negative 1. We get y equals a positive 4. And then for our x, we can jump to this equation here. X plus y, which is 4, equals 6. We subtract 4. We get x equals 2. So our values here are 2, 4, and 6. Okay, solving for our systems of equations. So I notice that the difference here is that this is a 6 where this is a 3. I'm going to multiply this whole thing by 2. So I'll keep the 3x minus 6y equals 12. And then here 2 times 2x will give me 4x plus 6y equals 2. And I'm going to add these and get 7x equals 14. The y's cancel out. Divide by 7, and I get x equals 2. For our y's, we can say 3 times 2 minus 6y equals 12. This becomes 6 minus 6y equals 12. Subtract 6 from both sides. We get negative 6y equals 6 divided by negative 6. We get y equals a negative 1 for our answer for number 9. Okay, number 10. I don't see any values that work out right off the bat, so what we're going to do with this top equation is we'll multiply it by 5, and this bottom one will multiply it by a negative 2. So I'm taking these numbers, multiplying and making one of them negative so they'll cancel out. That gives me 10x plus 15y equals 5. And this gives me negative 10x minus 14y equals a negative 6. I can combine these and we get 0 for the x's, 1y, and negative 1. So we get y equals negative 1. And then we can plug this back into either of the equations. We'll plug this into the top one. So 2x plus 3 times a negative 1 equals a 1. 2x minus 3 equals 1. Add 3 to both sides. 2x equals a 4, and we'll divide by 2. And x becomes a 2. Okay. On this equation, if you notice that this second one, we could divide it by 5 and we get the exact same number as the top, that would work out and it would cancel out. Alternately, we could try and manipulate it or multiply different values here. So let's do it with the substitution method. Let's write this as x equals 3 plus y, and then let's plug it in here for our 5. So 5 times a 3 plus y minus 5y equals 15. We distribute this through and we get 15 plus 5y minus 5y equals 15. If we subtract the 15s, then we get 5y minus 5y equals 0, which zeroes out. And what this is basically saying is these two lines, if we were to graph them, they graph right on top of each other. They're the exact same line. And so we have many solutions, because you could pick any value for y and it would work out and give you a corresponding value for x. Number 12. So on this one, we're going to rewrite the first equation as x equals y, and then we'll plug in for x here. We got 4x, and instead of x, we'll put a y, plus 10y equals a negative 7. This gives us a 14y equals a negative 7. Divide by 14, and so we get y equals a negative 1/2. And so if we plug it into x minus our negative 1/2 equals 0, so x plus 1/2 equals 0. And if we subtract 1/2, x equals negative 1/2 as well. All right. Number 13. On this one, I'm going to use the elimination method again. So I'm going to eliminate the y values here. So I'm going to multiply this side by 2 and this side by 3. That gets me negative 14x minus 6y equals 20. And this gives me 6x plus 6y equals negative 24. I can combine these. I'm going to bring this just up a little bit here. Negative 14 plus 6. There we go. There's our negative 8. Our x, our zeros cancel out. And 20 plus a negative 24 will give us a negative 4. We'll divide both sides by negative 8. We get x equals 0.5, or a positive 1/2. And then we're going to use the second equation. We'll say 2 times 0.5 plus 2y equals a negative 8. So if we take 2 times 0.5, we get 1 plus 2y equals a negative 8. We'll subtract 1. We get 2y equals a negative 9. Divide by 2. And y gets us a negative 4.5. Okay. And for our last problem, I'm going to plug this directly in for the y. So I've got 3x plus 3 times negative x plus 2 equals 6. I'll distribute 3 through, so I've got 3x minus 3x plus 6 equals 6. Notice that if I subtract 6 from both sides, I've got 3x minus 3x equals 0, which we get 0 equals 0. And so this is a many solutions. Once again, if we graphed it, those lines are overlapping on the graph. And so they intersect at every point. Okay, that is the end of chapter 14.